Hi guys, in this video we'll be discussing the problem of the day for Geeks for Geeks on 5th of January. The problem's name is find the longest string. The problem states that given an array of strings, you have to find the longest string which is lexicographically smallest and also has all of its prefix strings already present in the array. I think there's a bit of grammatical mistake over here, but anyway, so let's start with the question. So before we start with the question, let's understand what a prefix string is. So when we have a string, let's a b c, so this is a string. Let's simply write abc so as to not confuse it with the array. So the prefix strings for abc are a, ab. Let's say for a g h, so the prefix string for this would be a, ag, also agh. So these are the prefix strings for these arrays. So basically we'll start from the left, and for all the i's equal to 0 to I is less than n, if we start from the very left, that is from I is equal to 0, so the left segment would be at 0 and the right segment could be at 0 till n. So all the strings that can be constructed in this fashion from a given string are known as prefix strings. So with that we already know what the prefix strings are. Now what the question asks us to do is that they have given us an array. So array would be having any amount of strings. So the example they had given us was AB, ABC, ABD. In this we have to check for a string for which all of the prefix strings are also present in the array, and it technically is the biggest, and also if there are two strings that are biggest or have the same length, then we'll have to return the smallest like this the lexicographically smallest string. So over here, let's say if a has its prefix, so a is a singleton itself, so definitely that's valid. What about ab? So ab has a and ab as the prefix string, so ab is itself present, so let's just calculate for a. So do we have a? Yes, we do have a, so it's also valid. What about abc? So abc has three prefix strings, a, ab, abc. Over here we can say that a is present, ab is also present, abc are also present, so all three of them are present, so this is all valid. What about abd? So for abd we have ab, a itself, and abd. So similarly over here as well, ab is present, a is also present, abd is itself, so yeah, everything is present. So now all of these validate the first constraint. So the first constraint that was regarding the prefix string, so that is validated. Now the second constraint is that we need to select the string with the maximum length. So over here we have having two possible options, that is abc and abd. Both of them have a length of 3, so both of them can serve as valid answers. Now the third constraint said that it should be lexicographically smallest. Lexicographically smallest. So which amongst abc and abd is lexicographically smallest? So when we try to check it, like we can definitely check it by naked eyes, but how a computer checks is that it compares the first index, so they are same, then it moves to the second index, also they are also same, so it moves to the third index. Now the third index for the string a, let's call it a, let's call it b. So the third index for the string a is smaller than the third index for the string d, so it will automatically return 1. 1 meaning that a is smaller than b. Hence in our answer we'll be returning abc. Let's talk about the time complexity. So the time complexity they had asked us to offer was n log n, and the space complexity or the auxiliary space complexity they had asked was order of n. So with that in mind, let's try to develop an algorithm. Also, if you'll try to look in the tag section, you'll see a lot of tags like tries, bfs, data structures, advanced data structures. uh, you don't need any of them. Definitely you can try doing it via try, or you can do a bfs, all of that sort of things, but it's actually not required. We can achieve this time complexity and the space complexity by a very simple algorithm. So what I can say by looking at it is that I'll only be considering those strings in my array that actually have their prefix strings present, right? So for example, when I'll be having this array AB, ABC, ABD, when I'll start pushing the things into my array, I'll check is the prefix string of A present. So A doesn't have any prefix string other than A itself, so yes, I can push this. Can I push AB into my array? So AB needs to have a prefix string A. So do I have a A? Yes, I have a A. So I'll push this into my array, or a set or an unordered set. I can take any data structure over here. So personally I believe that I can take unordered map, or maybe unordered set over here, unordered set. Now the reason I'm taking an unordered set over here is that its complexity is low. So in order of n complexity I can store all the values, and in order of 1 complexity I can fetch the values. Cool. So then I can check for ABC. For ABC I'll be requiring AB and A. So yeah, these were also traversed already, and these would already have been stored over here. So in order of 1 time I can do a lookup, and I can confirm that yes, I can push this value into my array. What about ABD? So for ABD as well, I'll check my unordered set. I'll check that AB and A are already present in my unordered set. That means that they existed, right? So in this way, then I'll be having all the valid entries in my unordered set, and from the unordered set itself I can use the required values, or the value that has the greatest size and is lexicographically smallest. But wait, is it necessary that A would come before AB, would come before ABC, and come before ABD? It could be the case that A is something like ABD, AB, or ABC, something like this. So now when I start traversing it for ABD, I'll check, do I have a A? Do I have a AB in my unordered set? It will give me no, right? And I'll not add it. So this would become a wrong answer, because technically in my entire array A as well as AB were present. So how can I get rid of this particular problem? So a very simple solution is that you can actually sort the string. Now when we talk about sorting, we generally talk about sorting it lexicographically. So a smaller string, like a string which is lexicographically smaller, would come at the initial indexes, a bigger string would come at, or lexicographically bigger string would come at the next indexes. But over here I can sort them based on the sizes. So if I sort them based on the sizes, then a smaller string would always be present first, right? So A would come over here, then AB would come over here, then ABC, ABD, right? So this actually would make sense. What if the length of this two strings are same? In that case I can push any one of them, but for this particular question I'll try pushing the one like I'll try using the one with the lower lexicographical value first. So if I have ABC and I have ABD, then although both of them have similar length, but ABC is less than ABD, hence I'll try pushing it first. Now you might ask why this is the case, or why I'm coding it in this way. You can definitely do the other way around, or you can completely ignore this check. The only reason I'm making this certain check is because when I'll be storing my answer, so I'll only need to check if the current string which I'm able to process, or which I'm able to put inside my array, if its size is greater than the size of the string that's available in my answer, only then I'll have to update my answer. Because if I'm having this string of the same length in my array, and I have already lexicographically sorted the string with the same length, then that would mean that the string that would be coming at a index that is after the current index would be lexicographically higher. So I would be saving on some if statements, and the code would look much nice. I think that was enough of an explanation. If you still have any doubts, you can let me know. So now let's start coding it up. So over here I'm giving with the words, so let's sort it. Okay, sort words begin. words end. Now as I said, I don't want to sort it in the usual fashion, that is the lexicographical order, but I want to sort it based on its sizes, right? So I'll be using a anonymous function over here. You can actually make another comparator function and use it. It personally feels easy for me to use, so I use this. So whosoever size, so let's put a check over here. If the sizes are not equal, then I'll use the one which has a lower size. That's fine. What if the sizes are equal? In case the sizes are equal, then I'll use the one with the lower lexicographical value. Now I'll traverse for all the words that are possible, or all the word I'm having in my strings. I'll also keep a data structure like unordered set to keep a check on all the values or on the words I've seen. So let's call it seen itself, makes more sense that way. Then what I can say is that, okay, so if word dot size is equal to 0 is equal to 1, so if it's a single character, or seen dot count word dot sub str 0 to word dot sub str 0, okay, word dot size -1. In that case only I can add it onto my scene unordered set. So scene dot insert word, else continue. I actually don't need to write it, but over here itself let result denote the array I'm using. So, or the result is the final answer I'm going to return. So if result dot size is less than the current word size, then I'll reinitialize result with word. In the end, I'll simply return result. Now this should make sense, I guess. Let's try running it for some sample test cases. Okay, so the answer is correct for this. Also over here, the reason I've done a scene dot count word sub str, all of that gibberish, that's because what I'm simply checking over here is that in my unordered set that is named scene, I should be having a substring of this word that starts from the index 0 till the index n-1 or n-2, you can say. So except for the last index, all the strings must be present. So over here I'm doing the exact same thing. So for example, for a, b, c, d, e, f, I would be checking that whether I have a, b, c, d, e. So when I say word dot substring 0, so it starts from the 0 index and it checks for these number of characters. So it would be checking for n-1 characters. So it would be checking for a, b, c, d and e, and if this is present, only then it would be true. The other case is that what if I have a single character over here. So if the word size is 1, then also I can add it. So if the word size is 1, or I have the prefix string already present in my array, in that case I'll utilize this. I think this makes sense. So let's try to submit the code now. So you can see the code passes. Also, talking of the complexity, so the complexity of the solution would be order of n log n space time complexity. So this is the time complexity, okay, sorry, and the space complexity or the auxiliary space complexity is order of n. That is because we are using an unordered set over here that can take all the strings inside it, and all the strings are denoted by n, so the space complexity also becomes order of n. I think the code was pretty simple. Still, if you have any doubt, please let me know. I'll be putting a link to this particular code in the comment section, maybe in a pinned comment, so you can check the code from there if you have any doubts about it. That's it from my side. Thanks a lot, guys.